Right, question 6 is looking at a tyre shop, and he's going to buy 2 Dunlop tyres. So we've got 2 times our £62, so that gives you £124. You've then got 2 lots of the tyre and 2 lots of balancing, so that's £2 there and £1 there, so add it all on, gives you 127. You then add VAT, which is 15%, so if you work out 10% first, that's £12.70, and half that to get you 5%, which is going to be £6.35. Add those values then all together, which will then give you £146 and 5p. Part B is saying there's a tyre sale here, and it's £71.50, and that includes 15% VAT. What was the price of tyres before VAT? Well, if the VAT was 15% already on, then you've got 115% of what you originally had, and that equals £71 and 30p. We divide through by 115, so that gives you 1%. So £71.30 divided by 115 gives you 62p, and then you times that by 100, and that will then give you £62, showing that was the original value. Part C, you're told that VAT is to be increased from 15 to 17.5%. What number would you have to apply the old prices by to give you the new prices? Well, personally, I just work on, if you had £100 and you added 15% to that, you get £115. If you added 17.5% on, you get £117.50. So if you divide your £117.50 over your 115, that will then give you your multiplier, which will be 1.02, and that'll do really, but then you can write 17391, etc, etc, but that's fine. Now what I would say is the next question, I would put up there in one of the toughest questions I've seen at this stage of the paper, so I can't really see it being the same in the actual exam. But we've got squares are cut out of an A0 size rectangular piece of paper, which is dimensions of this. The shaded isosceles right angle is cut out of a large square of side 200 mils. More triangles are cut from the paper that is left after the squares have been cut out. What is the greatest number of these triangles that have been cut out of the large rectangular sheet of paper? So personally, what I would do here is start thinking about, alright, well, if you physically had to draw this thing out and you knew that it was 841 this way and 1189 that way, if I drew the first one in, which you said is here, we don't actually know the distance that this is taking up. So what would be quite nice is to work out the distance here, or all the way across. But if I take out this shaded segment, now we know both of these sides are x's, because you're told it's an isosceles triangle, and that's 200. So if I use Pythagoras to work out one of my x's, so it's 200 squared is equal to, because it's the longer side, squared is equal to x squared plus x squared, because these are 2x squareds. That gives you then 40,000 equals x squared plus x squared, which is 2x squared, half both sides, 20,000 then equals x squared. So then we get x equals the square root of 20,000, which is then 141.42. Now that's telling us then that this side here, so basically this amount here, from there to there, is 141. So if I calculate how many 141s go into this value, and also calculate how many 141s go into this value, what will that actually give me? Well, that will give me the number of squares to tell 141 by 141, so I just draw what I'm talking about here, there. Now within that square there's actually two triangles, isn't there? So if I work out how many 141s go into it, I'm working out here then how many of these triangles we can fit in. So if we do 841 divided by 141, and also 1198 divided by 141.42. So that goes in 5.9 times. And that goes in 8.4 times. So what we can say is that we can get 8 rows across and 5 rows down. So we've got 8 rows across and 5 rows down. If you times them together, that gives you 40. But I'm going to double 40 because it's 40 squares, and within each square there is 2 triangles. Now this is where I think it then gets very complicated. You actually realise here this is very, very close. So it's going down 1, 2, 3, 4, 5 times, and nearly 6, but not quite. But what you can actually do then is look at this part and think, well, could the triangles be put in any different way? Could you fit them in a different formation? Or what do you think? Well, if you think about it, you can actually fit squares in, if you're doing it as tight as you could here. So they would cover over each other, and they would fit in as a final row. Now that final row, each measure 200 across, but your first one is only in effect 100 here, and your last one is also 100 there. So you can get 5 200s in, your 200 times your 5, which is 1000, and you'll be able to fit then twice the amount, because you can see in the gap here 1, 2, 3, 1, 2, 3, 4, 5 there, and 5 on the top. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you've got another 10 on top. So if you add these two together, then you've got 90. Like I said, a very, very tough question. Question 8. Tom wants to clean the upstairs windows of his house. He decides to buy a ladder. The ladder has to reach exactly 3.8 metres up the wall of the house. So what I would do here is get yourself a drawing started. So we know that's 3.8 metres. To be safe, the ladder has to be an angle of 72 degrees to the ground. So that's 72 degrees there. What length of ladder should he buy? So you're working out this length here. So if we label up the different sides, this is a right angle, so that's hypotenuse, that's the opposite, and that's the adjacent. So we've got nothing at all to do with the adjacent this time. So if we write down sew, car, and tower, the adjacent we have no interest in, so those two go. So it'll be sine of the angle, which is 72, is equal to the opposite, which is 3.8, over the hypotenuse, which is x. X goes up, and your sine comes down. So it's then 3.8 divided by sine of 72, and that will then give you 3.9995 recurring. So once you look at it, you can actually say it may as well roughly equal, say, 4 metres. Question 9. Part A. The time it takes for a pendulum to clock swing from one end of its arc to the other and back again is given by this formula. Find the value of L when t equals 2, pi equals this, and g equals this. So we'll just write down first of all what we've got. So t is 2, pi is 3.14, and g is 9.81. So 2 times 3.14 is 6.28, square rooted L 9.81. Divide through them by your 6.28, so 2 divided by 6.28. So I'll put that down here. That equals the root of L over 9.81. Square both sides, so we're going to square all this. So that'll get rid of the square root on this side, and then times up by 9.81. So we've then got L, when we sub all that in, into our calculator. Of 0. And what's it asked for? Just as a value, so to 3 significant figures, 0.995. Part B then, I'll just fit in. Let's clear this part. Part B then says make L the subject of the formula. So we've got to basically repeat what we did, but this time using the letters. So T equals 2 pi root L over G. So we need to make L the formula. Well, first thing to do is divide by 2 pi. So T over 2 pi equals root L over G. Square both sides, so T squared over 4 pi squared, squaring both those bits. That's L over G. And then times the G up, so then we get that L equals T squared G over 4 pi squared. Question 10, you have to solve this. So times both sides up, so that comes here and this comes here. So the first line you'll get is x plus 3, and this side x plus 7, x plus 4. Once you've done that, you then times out both sides of the bracket, so x times x is x squared, x times 3 is 3x, x times x is x squared, x times 4 is 4x, x times 7 is 7x, and 7 times 4 is 28. Collect your like terms, which is just one side here, is your x's. 4x and 11x gives you, 4x and 7x give you 11x. Taking x squares off both sides, bring your 11x over here, so then you get minus 8x equals 28, and then x is 28 divided by minus 8, which then gives you minus 3.8.